Assalamualaikum warahmatullahi wabarakatuh dan selamat sejahtera to Madam Zaharia. Okay, my name is Fathihah Binti Ahmad Anuarizal and my matrix number is B0820100436. Okay, um, I would like to show our project team and alright. Where's the showing? We will present Project BEET 2343 Discrete Signal and System. Our is from Project Team N. Okay. Our group consists of 4 members, which is firstly Muhamad Hakim bin Abu Bakar B0820101138. The second person is Basyirah Binti Baharrudin B0820104440, while me, Fathihah Binti Ahmad Anuarizal B0820104436. The last one will be Najihah Binti Muhamad Zari B0820101365. First, I would like to talk about introduction. The first one, the Fourier Transform is an important image processing tool which is used to decompose an image into its sine and cosine components. The output of the transformation represents the image in the Fourier or frequency domain. In Fourier domain image, each point represents a particular frequency contained in the spatial domain image. Lastly, the Fourier transform is used in a wide range of applications such as image analysis, image filtering, image reconstruction, and image compression.
Assalamualaikum, my name is Basyirah Binti Baharrudin. My number matrix is 0820104440. So for my part, I will explain for task 1, which is I need to visualize the original image into the frequency domain using fast Fourier transform. So this is according for fast Fourier transform for task 1. At first part, which is for figure 1, we need to visualize the original image and then put the link for image at this bracket, and then the result it will be visualize the output for the image for the original image. And then for figure 2, we need to visualize the gray image, and then it's using this coding for the gray image, and then it will be change the color from the original image, which is it has no colors from the original one. Okay, for figure 3, this is coding for figure 3. We are using Fourier transform of an image, and then this is coding for visualize the output F and S, and then the result it will be a black image. It changed from the original one. And then next for figure 4, which is the center Fourier transform of image. We can see that this is a coding for visualize the center Fourier transform image, and then the result it will be same like the figure 3, but we can see that it has white dot at the center of image. Next for figure 5, we apply the log transform, and then this is coding for the output of log transform, and then the result it will be the gray image and then have a center white dot. For the last image, which is figure 6, we need to reconstruct the image, which is the coding it will reconstruct the image from the figure 2, seems like figure 2, which is the gray image, and then this is a coding that we use, so the result it will be seems like figure 2 because it reconstruct the previous image, which is we recall the image from figure 2. So this is the output, the last output. Okay, that's all for task 1. Thank you.
My name is Najihah Binti Zari, and I will be presenting for task 2. In this task, we need to apply a blur effect on original image using Gaussian kernel. This program shows how to apply different Gaussian smoothing filters to image using image Gaussian filter. Gaussian smoothing filters are commonly used to reduce noise. An image can be filtered by an isotropic Gaussian filter by specifying a scalar value for sigma. Image Gaussian filters allows the Gaussian kernel to have different standard deviations along row and column dimension. We can see from the picture the changes in the output image as we change the standard deviation value. The output image becomes more blurry as the standard deviation increases. When we apply the Gaussian kernel to the current pixel, an average of the color values of the pixel surrounding it is calculated by the value in the kernel. Larger kernels have more values factored into the average, and this implies that a larger kernel will blur the image more than a smaller kernel. A large sigma value results in a flatter shape, while a smaller sigma value results in a more pronounced peak.
Assalamualaikum. My name is Muhamad Hakim bin Bakar. For this assignment, I have done task 3. So for this task, the instruction want to detach the edge of original image as we change in the output image using Laplacian of Gaussian kernel. So to explain it, we can go to the MATLAB and see all the command used for this task. So the first function used, we use imread. We label it as imread. So imread is to detect the path of location of the image file in the computer. So then imshow function is to show the image, and we label it as a original image. For this task 3, we use as special function. We label it as h1. F special function is log7, then combined with 0.1 as a standard deviation value. So the task, we need to compare at least 4 output image with different standard deviation. So 4 different standard deviation used from 0.1 until 0.4. H1 is we label it as F special, log1 log1 7, 0.1 as a standard deviation value. I1 we label it as IM filter, is the command used to filter the image. IMshow is to display the output filtered image of a special function labeled as h1. Then we run. So the subplot is used to make it show together. We label it as image of sigma 0.1, image sigma 0.2, sigma 0.3, and image sigma 0.4. As you can see, the output become blurry and grainy. That's all from me. Thank you.
Okay, but for me, I would like to talk about conclusion. Based on this project task, firstly will the student able to visualize original image of group members into frequency domain using fast Fourier transform. Like, we also capable of converting the original image into frequency domain using the fast Fourier transform. Also be able to reconstruct the image to its real domain. Capable of applying a blur effect to the original image using Gaussian kernel. Also, we are able to know how to apply a blur effect on original image using Gaussian kernel. And also, capable of detecting the edges of the original image using a Gaussian Laplacian LOG kernel. So we will determine the output changes of the image. Lastly, we observe that as the value of sigma increases, the image will blur. So we also know that when the value of sigma increases, so the blur of image will be increased. Okay. Thank you. That's all for me. Bye.